Hello, everybody. It is Miss Hester, and this will be a review for Algebra 2 for our semester exam final for the fall semester. Per usual, at the start of any YouTube video, I'm going to be cringy, and I'm going to ask you to please like and subscribe to my YouTube channel because I know I have only 2 followers, and I kind of want more. I'm just kidding. So, what we're going to talk about today, I'm going to do one question from each row, because each row will be similar to a question on the exam. So I'm going to start, I'm just going to do one question per row. So what that will look like is, for example, I will do this guy, but I won't do number 2 because they will be very similar. A couple of them are not as similar as I would like to be, so I might do both, but that's just what I'm going to do. Okay, so I'm going to start with number 1 because if you start with number 2, you're weird. So what you're going to do here, all it is asking for is if this is 13, what is the value of this? So this is just a algebra 1 question essentially, and you're solving for x. So I'm going to add 9 to both sides. So I'll have 2x is equal to 22, divide by 2, divide by 2. X is equal to 11. Okay, and all I'm going to do then is I'm going to plug in 11 into the other equation. So I have 8 times 11 plus 12, which will give me 100 if you plug that into a calculator. And then one thing I forgot to mention to a couple of y'all is we're going to have Desmos for the final, and you'll have the TI-84s if you want them, but you'll have Desmos and all of that. So I'm going to show you how to do a couple of them in Desmos and how to do a couple of them without Desmos. So we're going to do number 4. We're going to be weird. So we're going to do number 4. Number 4 and number 3 are pretty much the same thing, just different numbers. Now, absolute values, this is going back to before fall break, kind of. We're going to pick at your brains a little. An absolute value can never be negative. I had y'all repeat that a ton, okay? But how we solve this, we know that since an absolute value cannot be negative, or cannot be equal to a negative, this inside stuff could possibly be a negative. For example, if we had the absolute value of negative 5, that's equal to positive 5. So because of that property of absolute values, we can say, hey, x plus 3 could equal positive 12, or x plus 3 could equal negative 12, because if we have the absolute value of negative 12, that's equal to 12. Okay, so that's why we're able to do that. So from here, we're just going to solve both sides. So we'll have x is equal to, 9? And x is equal to negative 15. And from there, to solve something that looks like this, we've solved this first equation, which is great and all, but we want to see where we satisfy both equations. Okay, so we're going to plug both of these values in and see if they both give us what we want. Okay, so I'm going to plug into our other equations. So we'll have absolute value of 9 plus 10, which gives us, I don't know if it's equal to 5. So absolute value of 19 is equal to 5. Does 19 equal 5? No, it does not. So no. Okay, let's try the other one. So we'll have absolute value of negative 15 plus 10 equals 5. We know that the negative 15 plus 10 is negative 5, which is equal to 5. And coincidentally, negative 5 in absolute value bars is equal to positive 5. So that one does work. Okay, so in this case, we didn't do anything algebraically wrong, but this answer just didn't work for our other equation. So only this answer would be our solution. So that's the answer that satisfies both of our equations. And like I said, number 3 is going to be very, very similar. Now, number 5 and number 6, I'm going to show you how to do on Desmos, okay, because it's easiest to see how they look on Desmos. So I'm going to go ahead and pull up Desmos. Let me see if I can do some split view here. All right, so I'm going to start with this guy. So all I'm going to do is I'm going to do my absolute value bars. I'm going to say, hey, absolute value bar of x minus 7. I'm going to close my absolute value bars. Then I'm going to do greater than 8. And if you zoom out just a little bit, I'm going to hide that. Okay, that is what your graph will look like. Now, how we write this in equation form is we are going to say, hey, we know that we are everywhere on the outside of, I think that's negative 1. Yeah, negative 1. So what we can say is, hey, x is less than negative 1. Now, we will not have the line under here for 2 reasons. First reason is we didn't start with a line in the first place, so we're not going to have a line in the end. But the second reason is if we notice in our Desmos, we have a dotted line, and that means we cannot be equal to something. So we won't have a line underneath. Now, the other side, we know or well, we've only covered half of the graph. We got to cover the other half, and the other half I believe is at 15. Correct me if I'm wrong in the comment section, I guess. But we know that we're to the right of 15, which means we are greater than 15. So x will be greater than positive 15. And that's how we can read that graph. Again, we won't have a line under here because it's a dotted line and we didn't start with a line underneath here anyway. So that's how you would do that using Desmos. And like I said earlier, on the final, you will have Desmos. So you would do this guy pretty much the same way. Just make sure you remember to have that line underneath. Okay. So in that case, we'll have solid lines instead of dotted lines. Okay, so that is it for Desmos for now. Okay, so I'm just going to go back and forth because I'm weird. So we're going to do number 8. Now, number 8 is, we briefly touched on this before fall break, but we're going to talk about it now. Okay, what I'm going to do, I'm going to do this in 2 colors per Miss Hester fashion. Okay, what I'm going to do the 3f of 2. What this is telling me is to, if my pencil will be nice, still won't be nice. Hello. Oh, that's helpful. Oh my gosh. Technical difficulties, everybody. There we go. Okay, so now what 3f of 2 is telling us is we're going to plug into f. Let's start with that. We're going to do f of 2. That's equal to 6 times 2 plus 1, because all I'm doing with that part is I am plugging 2 in for any x that I see. So that is going to give me 13. Okay, now this 3 part, this 3 that is out in front, this is telling me multiply all of f of 2, so 13 by 3. So I'm going to multiply 13 by 3, which gives me 39. Okay, so that's my first part. My second part is that g piece. So I have g of 3. Okay, and again, just like we did with f of 2, we're just plugging in 3 into g. So we'll have 10 times 3 minus 2. Okay, now that will give us 28. Now here, we are not multiplying g of 3 by anything like we did with f of 2. We are only plugging in 3 for x, and then we're done. Okay, and then from here, we're going to subtract. Okay, because that is the operation that is between these two things. So we will have 39 minus 28, which will give us, what, 11? I think 11. I don't know. Math is hard. Okay, so that's 11. And number 7 would be really, really similar as well. Now, number 9 and 10, I realize that they are the same question, and I don't know why they are. So yeah, those are the same. But this is going back to transformations, and we've talked about transformations several times. We talked about them whenever we talk about absolute values, whenever we talked about quadratics, and we're going to talk about them some more after winter break, because they are going to be the same for any function no matter what. So let's go ahead and start. So let's identify the transformation. So let's just identify the differences that we see between our absolute values. So I see a normal x here, and in my equation, I see this minus 4, and I see this plus 2. Okay, so I got to figure out what the heck those things do. One way of figuring that out is by graphing it. Okay, so I'm going to go ahead and graph this. I'm going to get out of my Desmos. I'm going to graph my parent function, which is absolute value of x. So there's my parent function, a nice little v. And then I'm going to graph my transformation, which was x minus 4, I believe it was plus 2. Okay, so what we notice is we have moved to the right and we've moved up 2. Okay, or we moved to the right 4 and up 2, because if we look at our vertexes, our vertex or our original is at 0, 0, and our new is at 4, 2. So that tells us that we moved to the right. That's what that 4 does. So we moved 4 right, and we moved up 2. That's it. Okay, so that's how that would work. So yeah, just graph it and see what happens. Now, these next few parts is mostly Algebra 1, but we're going to talk about it because I briefly touched on it when we talked about systems of equations a very long time ago. When a system of linear equations have no solutions is when they're parallel. Okay, and parallel means they never touch. So that means they will have the same slope. So what that looks like is we would have y is equal to 3x and y is equal to 3x plus 2. I don't know. Okay, that number on the end could be anything, but the slopes right here next to the x's are the same. Now, when we have exactly one solution is when they are perpendicular. And that is when, that is when they have opposite slopes. So we'd have y is equal to 3x. Let's just stick with this example. And then we'd have y is equal to negative 1/3 x. That's that opposite reciprocal. Those would be perpendicular. And then the last one is when they have infinitely many solutions. This is essentially just when they are the same equation. Okay, because if they are the same equation, they're going to overlap infinitely. They're never going to not be touching. And then I already kind of went over 14. If they're parallel, they have the same slope. That's it. Okay, so that's what that is. Or that's how we look at systems of equations in linear form. Now, for 15 and 16, what I'm going to say, just graph them in Desmos. That is the easiest way to find these. So I'm going to do number 15. So I'm going to pull up my split view because that's the easiest to see. There we go. Okay, so we will graph our first equation. So we'll have x plus 10y is equal to 2. And we will have x minus 2y equals negative 22. Now, when I make this go away, I want to know where these two solution or where the solution to the systems is. And that's where they cross. So I'm going to look at where they cross, which is right there. Now, when you are reading these types of problems, remember to read carefully and remember what it is asking for. I am asking for an x value here. So I'm looking at x equals negative 18. Do not be fooled into picking the y value of 2. Okay, it is going to be the x value of a negative 18. And you would do the same thing on number 16, except in this case, number 16 is looking for the value of y. So if we had the same equations, which we don't, you would look at at 2 for that part. So that is that. So now let's look at a word problem. Woohoo! We love word problems, right? So don't know why. Whoa, more technical difficulties. We're doing great today. There we go. Okay, so a tour group of Alamo in San Antonio has 23 participants. Okay, I'm just going to start highlighting some interesting information that I think is cool. So 23 participants is kind of cool. And then it's telling me it's 35 per adult ticket. And let's use purple. Wait, we just used purple. Pink. And 20 per child ticket. Okay, if the tour company made a total of $715 for the group, how many people in the group were children? Okay, so this is how we can write systems. Okay, so I know that there was a total of 23 people. So I have 23 people, and I know that the tour company made $715. Okay, so those are my two equals to things. But what I have to figure out is which pieces of information go on the other side. Now, how I like to remember it. Like goes with like. So for example, money goes with money. Okay, so I know that the two money pieces will go with my money of 715. Now I have 35 for an adult ticket. I'm going to conveniently call the adult ticket A, because adult. And then I will have plus 20C for child ticket. Okay, so those are my two variables A and C. Now, how the heck do I figure out what's equal to 23? Okay, it's in the first sentence. A tour group of the Alamo in San Antonio has 23 participants. It doesn't tell me how many participants are adults and how many are children. Okay, so that's what I got to figure out. So I'm just going to say A plus C is equal to 23 because I mean, if there's A adults, so let's say 5 adults and then 20 children, I don't know. We got to add those two numbers up to get the total number of people in the tour group. Okay, so that's how we would set up that system. And from there, we would do it like we did 15 and 16 right above here, graph that in Desmos, and you're good to go. And I think for some reason, 18 is the same question. So ditto. There we go. I don't think that's how you spell ditto. I think it's D-I-T-T-O. Anyway, I'm not an English teacher. So ditto on number 18. So that's that. So now let's move on to 19 and 20. 19 and 20, again, we are going to graph them because they are systems of equations, but we have to be careful with what this is asking us, okay? This is asking us what is the value of x minus y, and the other one's asking for x plus y. So we have to figure that out first, okay? So I'm going to graph these. I'm going to graph number 19, and I want to see what it tells me. So I will have 4x minus 3y equals 6. Blink. There we go. Then we'll have 2x plus y equals 18. Okay, so there's my system. There's their solution. Okay, so the solution is at 6, 6. Okay, so my solution over here is 6, comma 6. Now, this means x is 6 and y is 6. And I want to know what x minus y is. So that's literally all I'm going to do. I have 6 minus 6, which gives me 0. Okay, so you have to be careful. You can't just stop here. You have to plug in the rest of the equation. Okay, you have to. Okay, so now let's talk about some complex numbers. Okay, this is where a lot of y'all struggled on the DCP, and I yelled at all of y'all. Okay, so when it says sum, you add, please. Otherwise, I'm going to be losing all of my hair over winter break, and I will be so mad at y'all when we get back. Ooh, my iPad's mad at me. Guess my iPad's on y'all's side. Anyway, so you're summing, you're adding. Okay, so you're just going to say, hey, 2i minus 5 plus 8i plus 13. Combine like terms. 2i plus 8i is 10i. Negative 5 plus 13 is positive 8. Math. Okay, so be careful. Read your questions carefully. Okay, now the next one is talking about a product. This is where you would multiply. Okay, so this is where you would write something like this guy. Now, a lot of y'all may have forgotten how to do this in the calculator, but I'm going to show you how to do this in the calculator. This is not a Desmos thing, but this is a TI-84 thing. There is a way for you to change your calculator into imaginary mode, if you will. So, I'm going to pull up my calculator, my handy dandy calculator. Slide over. There we go. Okay, so there is a mode that you can put your calculator into. So you're going to hit mode, and you're going to scroll down into your calculator until you have A plus BI highlighted, and you're going to hit enter. And now it'll be highlighted in black. And you'll do second quit or second mode to get out of there. Now, this is where you can literally just type in your equation. So I'm going to open a set of parentheses. I'm going to put a 7. Now, to get the I, you're going to do second and then the period. Okay, so 7i is now on our screen, so we'll have plus 2, close our set of parentheses, and then we'll do 2 and then second the period to get the I plus 1. We are multiplying, and there is our answer. Negative 12 plus 11i, and I'll go over this the day of the final to make sure everyone's aware of it, and it makes it easy peasy for everybody. But that is how you would do that. That makes your life so much easier. You don't have to do any math, and you don't have to worry about the I squared term. Okay, so that's something. So I'm going to close that. Okay, so this next part talks about figuring out which equations are the same. Okay, now what I want you to notice about all of these options, this is all vertex form. Okay, so I want to know the vertex. I'm going to graph it. I'm going to use Desmos. If you have Desmos, use that tool. That tool is there for you. It is there for a reason. Whoa. There we go. Okay, so I'm going to have x squared minus 8x plus 17. There we go. Okay, so my vertex is at 4, 1. Now, I can immediately eliminate A and B because they have a negative 1 as part of their vertex. But now, what I need to figure out is I need to figure out which 4 to choose. Okay, remember vertex form is h comma k, where it is x minus h squared plus k. Okay, so the sign always flips on h. So if we have a positive 4 here, which we do, it will be x minus 4. So in this case, it would be C. So you have to be careful with that. But again, the main thing with this question, use Desmos. If you have it, use it. It is there for you. And it's there for a reason. Okay? Okay. What are the solutions to the quadratic equation? So there's a couple of ways that you could do this. You could graph this. I will show you how to graph it, and I will also show you how to do it algebraically. So we'll have 5x squared minus 15x plus 10. Now, once I do that, it's really, really tiny, but there it is. Okay, you can look at the x and the two x-intercepts. So in here, we'll have x is equal to 1 and x is equal to 2. What you could also do is you could factor this. Okay, so I'm going to go ahead and do that. And that is using a couple of things. First off, I notice that all three of those terms are divisible by 5. So I will have 5 parentheses x squared minus 3x plus 2. Okay, and now this is the piece I only care about. I don't care about that 5. I'm just going to bring the 5 along for the ride. I don't care about it right now. I'm kind of ignoring it for a little bit. Okay, so we will do big X method. So I'm going to multiply to 2, but add to negative 3. So I'll have negative 2, negative 1. Okay, so what a lot of y'all messed up on during the DCP was this part. Okay, a lot of y'all stopped here and said x equals negative 2, x equals negative 1. No, you have to flip the sign. It is x equals positive 2 and x equals positive 1, which was the same thing that we got when we graphed it, okay? But you could do it both ways. Either way, whichever one is easier for your brain. Okay, so that's that. Okay, number 27 or number 28. Okay, either one. What this is asking for, it is asking for the x value of the minimum. When it asks me for a minimum, I automatically think vertex. Okay, so I got to find my vertex here. Now, if it's the x value of my vertex, I know that I can use x is equal to negative b over 2a. Okay, so I will have negative 12 all over 2 times 1, because that's what my a is. So I will have negative 6. X equals negative 6. You're done. Okay, that's it. Okay, now if it was asking for the y value, you would plug that value back into your equation, and you're good to go. Or you could just graph this, whichever one you want to do. Again, whatever works for your brain best. Okay, number 29 is tricky. Okay, it is tricky because you have to read it. Okay, what is the sum? Again, when we say sum, we add, okay, of all of the values of x that satisfy that equation. So I have to do a couple of things here. First of all, I have to solve this. Okay, so I'm going to solve it by factoring. I have negative 24, positive 10. So I'm going to multiply to negative 24, but add to 10. So I'm going to have positive 12, negative 2. So I have x plus 12, x minus 2. X equals negative 12, x equals positive 2. Now I want to find the sum of all of the x values that satisfy that thing. So I will have negative 12 plus 2, negative 10. That's it. Okay, so with this one, you have to be careful. It's asking for sum of all the values of x that satisfy that equation. Okay, so you have to solve it first, and then you have to add your solutions together. That's all. Okay. All right, this one we did a whole project on, and we did a huge scavenger hunt on this kind of stuff. This is projectile motion. Okay, so the function above models the height, h, in feet of a football t seconds after being punted in the air. What does the number 2 represent in the function? So I'm looking at this guy right here. All it is, your initial height. Okay? So, let's say here's where we punted the ball. Here's the ground. Whee! There's our football. Okay? So this was our 2. We were 2 feet off the ground when we punted the ball. Maybe we were on like a platform or something. I don't know. Okay, so that's what that means. Okay, when we are dealing specifically with standard form, which is this guy, okay, if it's the last number, that's your initial height or your y-intercept. Okay, when you are the last number here, it is your y-intercept. Okay, let's see. Okay, if the ordered pair xy satisfies the system of equations above, what are the possible values of x? Okay, this one you could graph as well. Okay, so we're going to go ahead and graph it. I don't remember what the equation was because I am a dummy. There we go. So we'll have y is equal to x squared plus 8x plus 12. And then we will have the equation 12 minus x. I'm going to make that go away. Zoom out a little. There we go. Okay, so our possible values of x would be these 2 points that are here. Okay, so we will literally just write those. X equals -9, x equals 0. And be careful, it is asking for your x values. I don't care about the y values. I don't care about 21 and 12. Yuck, no. Okay, so I only care about those. That's it. Okay, so again, if you have Desmos, use Desmos. All right. All right, last few. Ooh, we're almost done. Woohoo. Okay, so in the figure, the line TV, so this guy is parallel to this guy, okay? And the line SZ, wee, is that guy, okay? The angle SUV, so this guy, is 120, okay? So this is 120 degrees, okay? What is the value of, excuse me, WXZ? Now, this is a geometry question. If I have two opposite angles, or two parallel lines crossed by a transversal, those two opposite angles will be exactly the same. So this is 120 degrees. Okay, and I think, yes. So, oh, YXC, sorry. Okay, so YXC is the other angle that it asks for here. So that one would just be 180 minus 120, so 60. Okay, so again, if we have two parallel lines crossed by a transversal, these two angles are the same, and these angles will be the same. Okay. All right. Okay. Now let's go on to triangles. Right triangles LMN and PQR are similar. Okay. Now we've talked a ton about what similar triangles are. Okay. They have to have the same angles because they could be completely different sizes. Okay. But they have to have the same angles. Where M is the right angle. Good, I drew that right. Woohoo. So that means Q is also our right angle. And angles L and M correspond to angles P and Q. Angle L has a length or a measure, sorry, of 25 degrees. Okay, so I know then because these two triangles are similar, this guy must also be 25 degrees. Okay, and I know that a right angle is 90. So all I'm going to do, I'm going to add those two up and subtract from 180. So 90 plus 25 gives me 115. 180 minus 115 is a number. Let's see, 65, maybe? I don't know, 65 question mark? I think so. Yeah. Well, is it 55? I think it's 65. If it's not, correct me in the comment section or whatever. I'm doing math very late at night, and this is not a good thing. Okay, but that is 65 degrees, hopefully, maybe. Yes. So that is that. Okay, and so with these types of problems, just draw a picture. It's helpful. That's it. Okay, and I think that's all of our review. Woo-hoo-hoo. Okay, so again, if you have Desmos, use Desmos. It is there for you. It is there to help you. I'm not trying to make this exam super uber hard and screw you over at the end of the semester. No, I'm not trying to do that. Okay, I'm trying to give you the tools to help you best succeed. Okay, so again, if a problem can be used with Desmos and can be solved easily with Desmos, use Desmos. Okay. Other than that, that's all I've got. I hope this video was helpful. I hope you like and subscribe to my YouTube channel because I want more than 2 followers. Woohoo! And yeah. Okay, bye!